students make the practical research and trains in the real airport St. Petersburg. And you can see the photos of our students during the practice and the educational during the second year of their education. And now I want to show for you the special presentation video file about the information about our university. One moment. This video file is a slideshow about the some main points in the life of our university. This video file shows the main topics of students' life, and some main events of our university 1 year ago. So let me introduce for you information about our new laboratory. The new laboratory aims to develop and operate various unmanned aerial vehicles and their control systems. Drones find application in different fields: monitoring, cargo delivery, video shooting, and for their successful application, it's necessary to know the features of control and operations, to be able to perform maintenance, detect the troubleshoot and unmanned aircraft systems, to be able to apply technical means and equipment used to control the flight of an unmanned aerial vehicle. The laboratory conducts work in the following areas, and you will see these areas in this presentation. Development of new flight control algorithms and new software and hardware for navigation. Development the optimal aircraft schemes and design study of aerodynamic properties. Development of intellectual aviation control system and the practical research for the aviation and other technical spheres. Solving practical tasks of cargo transportation. It's very important in the field of the delivery of cargo or warehouses tasks. Modeling of different flight models and new aviation technologies. Solving interdisciplinary problems, searching for the optimal solutions for drone systems, and development of informational and software of processing images and video streams from drones. It's very important. And we are actively working towards the competence of the future. And so let me introduce for you the Nikita Bagatov, and he will show for you the information about the drone sphere and information about our laboratory. And you can see here in our Zoom section the user about the Institute of Aerospace Equipment, and in this Institute of Aerospace we will stream the real-time internet connection from our real flight zone. Nikita, please.
Yeah, thank you very much, Nikolai, and thank you once again for the great introduction of our university. I have now sent the link to our YouTube translation from our flight control center. You can also get there if you want to see our flights, because today we are going to show you not only presentation, to show you not only our quadricopters, but also to show you the real flights in a real flight zone. So before we start, once again, my name is Nikita Bagatov, and I want to ask you, all of you, to unmute your microphones now. I know that today we have a lot of people from the countries from all over Europe, not only Europe. I want to unmute all your microphones now and to say hello to each other on your own language. Please, let's do it right now.
Hei vaan kaikille.
Moro.
Moikka.
Hei.
Päivää. Hyvää päivää.
Привет.
Hei vaan kaikki.
Was there German from Anya?
The German is hello, yeah? Grüß Gott, oder? Really, we have someone from Germany today, yes?
Yes, we do.
Okay, let's get started. One moment, I will ask you, Nikolai, please. Выключите звук, пожалуйста, на компьютере, я сидел. Thank you. So, let's get started with our presentation. So, do you see my presentation now? Do you see it?
Yes.
Я не могу ее запустить. One moment, please. Can you see my demonstration, or you see the overlay of Zoom now? Yes. Ivan, could you please answer?
We see the
Do you see
presentation.
the overlay of Zoom or not?
I do see the slides. The drone's even better than you imagine. It's, you know, it shows the entire screen. That's how I see it.
Yeah, it was okay before. It was only the presentation mode.
One technical problem, sorry. And now we'll make some changes in little presentation and then restart it now. I will now say that in our university, we have a special science school, and many students make their own research in the field of drone systems. And our laboratory is the final stage of the research of this scientific schools. And I am an associate professor of the Department of System Analysis and Logistics, and it is one of the main science research in our university at this moment. Long-distance cargo transportation and the warehouses logistics. Is it all normal?
Yeah, now we can see Nikolai. It looks fine.
One moment. Excuse me. One moment.
Okay. Now we have fixed the technical issues. Nikolai, is it working? You see it on your screen? It is okay. So now we are ready to start. So drones. Everyone from you, I think, have already met these technical vehicles in your life. Of course, you can get them in all shops, in all shopping center, in all over the world. For example, you can go to the shop, buy any model. As a rule, the usability of these drones is really trivial. For example, you can fly them, you can make a movie, for example, with the DJI drones or Parrot drones, or you can even use them for drone racing, a really modern way of drones usage. Some of you can also watch on your neighbors if you are not trust them. But what if I say to you that nowadays the usability of drones is extremely huge and extremely high because of the really increasing numbers of the drones manufacture processes. So that is the modern ways of usage of drones in industry. Of course, first of all is delivery. A lot of companies like DHL are now using the drones for delivery of small cargos. For example, DHL now uses it in China and also, as I know, in Norway. Drone monitoring systems are using for the safety on the security objects in the security fields. Inventory and other in-house logistic operations, you can use drones even for inventory. That is really important for logistics, for aviation sphere, for the big warehouses, for the big house. For example, even our laboratory now has one project with the airfit identification of the roads in Hull. Farming. The Chinese farmers are using their drones for farming, for making some things with the plants and so on. Movie production. I already told you that we can use the drones for the movie, but the big movie companies are using the really big drones. They even put on them their 4K cameras, and a lot of movies that you can see now in cinemas are made with these great drones. The sport, the drone racing, I already told that a great and modern direction of the drones usage. And one important for us sphere is the cooperation with other automatic systems. That's what we are doing in our laboratory. On the right side, you can see the picture of the Volvo truck. That is one of the last Volvo projects. They are going to build the robotic truck, and the drone will help this truck to make the 3D visualization of the space around this track, and that will allow this track to drive into the career or other spheres. So the main idea of the drones is that they are modular, and you can use them in all the spheres that you could even imagine. That is the numbers of the unmanned aerial systems market. You can see that within the years we have the increase of the usage of drones in all spheres. That is a military, private, and commerce. Of course, nowadays the military is the most widespread sphere of the drones usage. That is true, but for me, really nice to see that also the private and the commerce usage is increasing with the years. Now, I would like to tell you also some words about our laboratory where I'm sitting now. You can see now I'm sitting in our laboratory. We have a great team. You have already met Nikolai Mayorov. He's our team leader. The head of laboratory is Anton Kostin. He's in the hardware team. I'm Nikita Bagatov, lab engineer. We have also two great engineers, Daniil Yelenin and Evgeny Voznesensky. They are also working in hardware and software team. Our laboratory is really young. In this year, we just celebrated our first birthday. We are only 1 year old, but already now we have become the control center, for example, of the BRICS challenge of drones operating. And we have already made a lot of projects with the drones. We have written a lot of science articles. And I think that that is a really gorgeous result for only 1 year laboratory. On these pictures, you can see some photos of our environment. We have a great airfield. You will also see it today. We have a working zone. We have a meeting zone. We have a 3D printers. We have five 3D printers, the 4 Anycubic, and one of them stands behind me, our biggest printer. And some words about our operations. Nikolai Mayorov already told me, I will repeat you once again. Drones development, we construct drones. So we construct not only drones, also the planes. Science education programs, because we are working in the university. We are working with the students of college. We are working with the students from university. We have a lot of study programs like this. Today, we're also introducing you our new international study program for you. We are the training center for the World Skills Challenges. Our laboratory has become the pilot center for the World Skills Challenge in Russia and also World Skills BRICS Challenge. We are making the project management and commerce program for our partners. Of course, one of the most important side for us is the international cooperation and spreading. We are always open for cooperation. And we are using the simulation. That is really important nowadays because of coronavirus. We are not able to meet all our partners. Sometimes we are even not able to meet here inside the laboratory. That is why we, together with our partners, we produce the simulations of the drones environment, of drones flying, like gazebo. We will also talk about this a little bit later. And of course, automatic transport decisions development. That is what I will talk to you a little bit later. So other photos of our team. Our great partner is a Copter Express Russia company. That is the photos from the education program AeroHard, one of the most important for us partners. Some certificates. All our employees have the certificates of increasing their skills in this field, and the practice time for you. So now I will turn off the presentation because now you need to see me. Okay. So let me to introduce you the Clover 4. This is our most favorite, our most popular and most widespread copter in our laboratory and in Russia too. We use it not only for coding, but also for the training programs for piloting, FPV piloting, and so on. So that is how it looks completed. Yes, you see that it has 4 engines. It has a place for the battery. It has the down deck with the camera. I will also tell you why we have it. It has the LED light for some also implementation for some signals from the copter. We can also understand how it works. And now I want to show you all the parts from the drones separately. So we will begin from the most important part of the drones. It's called the flight controller. That is a flight controller, X-Racer 4, and it uses for the drone flying and the drone control. Inside this little thing, we have a gyroscope,
sorry to interrupt.
To this thing, we connect all other devices from the drone. It is the radio control. It is the regulation.
Can you hear me, Nikita?
The regulation of the rotation of our engines.
Because I have a problem with my
So this is one of the most important things, and it is situated in the upper deck of the drone right here. It's situated right here. Next goes also important thing. That is the electricity pay of the copter. Of course, quadrocopter is electric vehicle, and we have to power it. So we power it with this pay. You can see that we have 4 cells for each engine and the big line for the battery. So to this pay, we connect all other devices, and this pay responds to make the right electricity voltage to all other devices. Because of course, the different devices in drones, engines, regulation control, and so on need different voltage. So I want to ask, is everyone good by sound? Do you hear me completely? Everything okay?
Everything is okay, but can you please stop the presentation so we would see the bigger picture of you and your demonstration?
Really, you do not see the big picture of me?
No, stop the presentation so we can see you.
But you can swap the screen. There is like the controls above the about the participants. There is a shared screen with video, so you can use that.
Yeah, no problem. That is no problem. Really, I thought that everything goes okay. I will now just, for me better to reconnect. Just wait a second. Really, I have just downloaded the Zoom to my Mac the first time, and really better to use it in a website, in Chrome or Safari, something like this. One moment, please.
One moment, please. One moment. And we will restart.
So now can you see me better?
Much better, thank you.
Now it was better. So the picture now is good. You can see me in a white screen, yes?
Yes, everything is good.
So do you want me to repeat once again some words about the quadrocopter, about the flight controller? Maybe you haven't seen something properly. For me, it is no problem to show you once again. Do you want?
Yes, maybe if you can show again, because it was very tiny in the small picture only.
Very tiny. So the quadrocopter or the parts from quadrocopter?
I don't know. Maybe all again.
Yeah.
But just very short. But all again would be great.
Okay. So all again. So once again. Our drone, Clover 4, I already told you about this. So it looks like this from the side, from the upper deck, the place for battery, our bottom deck. You can see the camera. We use this camera for navigation. I will also tell you why. You can see the LED stripe, LED light for the signals from quadrocopter. So, okay. And once again, the flight controller. You can see the pins for the engines. Here are the pins for radio control, pins for navigation, and so on. So this little thing is responsible for the drone flying, for the drone control. So now you will see it properly, yes?
Yes.
Fantastic. Many thanks.
Fantastic, yes. Really good. Really good. And once again, the electricity pay. This responds to make the right voltage to the all drones objects, to the all drones electric objects. So yes, because all of them need a different voltage, and we use this pay to connect to the battery and then to deliver the electricity. First of all, of course, to our 4 engines, and then to other devices that are situated on the quadrocopter. And when I'm talking about the engines, here is our engine, the simple electric engines with the prop. Here, here, the inside image of this engine, and we use it together with the electricity speed controller, ESC. This controller, it looks like this, and it responds for the changing the speed of rotation of our motor, of our engine. Because when we are flying the drone, to move it in a space, we have to change the speed of rotation of the front engines and to slow the rotation, for example, of the back engines. And then it will go like this to the back. If we want to go forward, we increase the rotation of the backward engines, it change the positions and go forward. So now you understand why we have to change the rotation speed of all engines. So then goes the radio control. I hope you understand for what we need the radio control panel, because we are using the radio to operate the drone. Radio control, it looks like this. And this we connect to our flight control like this. And now the drone is ready to operate. This is our small on-plate computer called Raspberry. Please answer me, do you know what is it Raspberry Pi? Someone maybe knows.
I have a few of them here on my table.
You have it. Really good. So you know for what we need it. We use Raspberry Pi controller for the autonomous flight because all the operations are not able to complete in a flight control. So we use the Raspberry Pi. We download there the operating system of of Ubuntu, and after that we are ready to implement it with the database of drone navigation. I will tell you about this a little bit later. So this small computer is situated on the bottom side of drone, right here. We have it here, and we connect this plate to our flight control by USB. Then goes the rangefinder. Rangefinder, it is a laser rangefinder. We use it to control the height, the altitude of our drone in real time. And also with the rangefinder goes our bottom camera. Bottom camera is used for autonomous flight to see our markers. I will show you a little bit later how it works, but we use it for the automatic flight. And both these things we connect to the Raspberry Pi. So you see that there is a pin to our camera, and we get it connected by this line to the Raspberry Pi. So that is the main parts of the drone. Once again, I understand that maybe something is not understandable now because we are not offline, we are talking in online. So I think it would be better if you will now have some questions for me about this drone. If you want to ask me something, how it works, just do it now and I will be able to answer you. Do you have any questions?
Nikita, what is the battery that you use and what is the lifespan of the battery?
So the battery that we are using, that is the 3-cell battery and the 4-cell battery. So you can see them on the screen. For the automatic flight, we use the 4-cell battery because it can fly better and longer. So that is a simple. You know what is a 4-cell battery? You don't know.
No. No.
Maybe Anton, could you please help me to say what is it, the 4-cell? Да, 4 ячейки, я тебе переведу. One moment. I also really glad to introduce you, my friend, our head of our laboratory, Anton Kosin. He is also working with us, and he will be able to properly answer to your question. I will translate him. So, Anton, your word.
Всем привет, хай, народ.
Pleasure to meet you. Hello.
Давай сначала я расскажу, из чего состоит, да, аккумуляторная батарея.
Yes. So, first of all, we will tell you the basic parts of the battery, what it consists from.
Соответственно, аккумуляторная батарея состоит из аккумулятора, самих ячеек.
So the battery consists of the, of course, accumulator, the 4 cells. We have 4 cells here.
Силового разъема.
That is the cable for the power cable.
Который подключается к квадрокоптеру.
Yes, which is connected to the quadrocopter. I already show you how we connect it, so we can now do it on the camera. So we connect it like this, and you see that the battery is now connected to our electricity pay. So please continue.
И также состоит из балансировочного разъема для зарядки.
So and this part we use for this is the rechargeable connector of our battery.
Далее я расскажу про основные характеристики аккумуляторной батареи.
So now we will tell you about the main characteristics of our battery. So please.
Да, я думаю, вы знаете, что существуют две основные характеристики у аккумуляторной батареи.
So we hope, we don't know, but we hope that you know that we have the two basic characteristics, two basic operations of the battery.
Емкость.
So its capacity.
И напряжение.
And the voltage.
Соответственно, есть еще не менее важные характеристики, такие как токоотдача.
Oh, wow. Это только отдача.
Только отдача.
So really, sometimes it is really hard to translate to English these words. The только отдача. Как бы это правильно сказать?
Напиши фактически сила тока.
Power output, maybe.
Да, сила тока, можно сказать.
Sorry, please?
Power output.
The power output, yes, something like this, yes.
Да, это вот одна из самых важных характеристик для аккумуляторной батареи.
Yes, one of the most important characteristics of battery,
которая используется в квадрокоптерах.
Which we use in drones.
Как вам Никита сказал, данный аккумулятор состоит из 4 ячеек.
Yeah, so I have already told you this battery consists of 4 cells.
И напряжение у каждой ячейки примерно 4 вольта.
Yeah, and the voltage of each cell is probably the 4 volts.
Да, соответственно, когда мы последовательно соединяем 4 ячейки, у нас получается 16 вольт напряжения.
So when we connect them one by one, we have the combined voltage is the 16 volts.
Это необходимо для того, чтобы... Только отдача, мое любимое слово, видимо.
Ну да, electricity output нам уже подсказали.
Да. Значит, это необходимо для того, чтобы увеличить ток отдачу ячеек в целом.
So this we use to increase the electricity output of each cell.
И, соответственно, поднять общее напряжение.
And so we increase the wall voltage of the battery to the drone. So now,
yes, many thanks for your explanation. I would have 2 more questions. So first question would be, how heavy is the battery? So what is the weight of the battery and how far can you fly with one of these batteries?
A good question about the weight. Yes.
230 grams.
Yeah, some 230 grams. And about the duration of flight, from 10 to 15 minutes.
Okay. Very interesting. Many thanks.
You're welcome. Any more questions about the battery or electricity units of drones?
Is there a particular reason?
Go ahead, Timo.
Okay.
Yeah, go ahead.
Question about the technology in the battery. You seem to be using the lithium polymer batteries. Is that the optimal for drones at the moment?
Could you? Yeah. Thank you, Nikolai. We have understood, but it depends. On the occasions, it depends what result we want to get. Of course, if we want to make the long flight, automatic flight, we use only 4 cells battery, because for us it is much more longer by flight. For drone racing or for some different occasions, we can use also the 3 cells battery. So for us, for me, for Anton, anytime we will say you that we will use the 4 cell battery because it is longer, and then we can do much more things in one time with no recharging of the battery. So the 4 cell for us is better.
Okay, thanks.
Okay, Ivan, you had a question.
Well, I had the question about transportation of items. So with this particular model of the copter, what items would be realistically carried and for what distances if, let's say, a logistics company would get a fleet of such copters? So what exactly, what distances and what types of items could be carried? Letters, I don't know.
So if we are talking about the Glover drone, about this model, of course, you can use it for delivery, for some objects. I will say that we have one project based on this copter for delivery, but sadly, this project now is not in our laboratory. We have sent it to one festival, for one technical festival, and there we have 3 cells. We have on this copter 3 cells for tiny objects. So, for example, you can deliver with them, for example, 3 such plates. So if we are talking about the weight, which weight we can hang on with this drone, it is not really big, not really huge weight. I think that maybe 1 accu and the weight which is similar to the weight of 1 accu to the bottom we can hang on, and then the drone will fly maybe by kilometers. It is really hard to say. Антон, как думаешь, если мы подвесим 1 аккумулятор на дрон, второй снизу, как объект, сколько мы полетим в километрах? Десятка, нет, меньше. So we have. So if we will calculate this from the maximum speed of this drone, the maximum speed of this drone is 60 kilometers per hour. And maybe no, we are not speaking about the autonomous flight. We are speaking about the control flight with the one way. So I think that within a 10 minutes, maybe 6 or 7 kilometers, we can afford to ourselves to do it. So my answer to you is the weight similar to the weight of one Akku, and the distance from 6 to 7 kilometers.
Okay. And then you mentioned autonomous drones. So have you tried in your laboratory already drones that somehow have navigation system, so that could actually go from point A to point B without being piloted?
Ivan, of course we have it. What is more, I have it in my presentation, because the next step, I want to introduce you is the automatic flight, because our laboratory is based on the automatic usage of drones. So of course we have this system. Of course we can do it. Yes, of course we will even show it to you in real time. And also, I should mention, I have forgotten to show you, we also have the FPV control system. So this system is used for the drone racing. You put one more camera to the front of drone here, and you can control it by this screen. I will now show you. So here you have a screen, and here you have a signal from the front camera from drone, and you can control it in the first-person mode. This helmet is used for the drone racing all over the world. So we also have some study program for our students in a drone racing systems. So any more questions about the drone construction from you?
Yeah, I had one. Okay. Is the output voltage of the battery, is that a standard, or do you play around with it? Because naturally with the cells you can go put them in series or in parallel.
Now for us it's standard, because we are using the parts, the pay that are working with this voltage. So for us it is standard, yes.
Okay.
Any more questions? Okay, if there are no questions left, I'm ready to go to another part of our meeting. Now I will use the demonstration screen. One moment. Yeah. Can you see now my screen? Is it okay? Now I will ask this now every time, because from the last issues. So we already told you about the automatic flight. Of course, that is one of the most modern ways of the drones, usability of the drones exploitation, and we are using it and researching it. So what we do, first of all, we have to write the code on Python. We are working with the Python language. We write them in Sublime Text or Microsoft Visual Studio or any else. After that, of course, you have to compile it and download to the drone terminal. I already told you that we use the Raspberry Pi computer, and there we have our operation system based on Linux, and there we download our code. Each of these computers have a special terminal. We can connect to this terminal by Wi-Fi standard, and we can control our quadrocopter from even laptop, mobile phone, tablet, even watch, if you can do it. So really from any device which has a Wi-Fi standard. And after that you fly. So how do we navigate in space? We call it Aruka markers. Do you know what is it, Aruka markers? Somebody knows what is it? No. Aruka markers, they are like a QR code, but they create the navigation map for the drone. So you see from the left side, that is the real Aruka markers field in the real life, and from the right side, that is the Aruka map in the terminal, in the memory, in the hardware of our quadrocopter. It looks like this. I already told you that we have the small camera that is situated on the bottom of the drone, and with this camera, our drone can see these markers and initialize them, and then drone combines the marker which he sees in the real life with the markers that is situated in the memory of drone, and then he is able to move around these markers in his own navigation base. You can even ask him to go to the left side, to the right side from this marker. I will show you how to do it a little bit later. So once again, easy graphic information. We have one marker, we have second marker, we have our drone. So drone initializes the first marker, and then he gets the command to fly to another marker. It's simple, goes to the right marker, and after then that he returns back to the other marker. Oh, sorry, wrong button. And then it goes to the left marker. And that's what drone sees in his software. So you can see that he initializes all the markers. Each marker has ID. It depends also on your production. It is not only 100 ID. You can make 1 ID, 2 ID, 3 ID, and so on. Each marker has a 3D space. You have X angle, Y, and Z. And drone combines this result to his own navigation base. And this is how we program it. From the left side, on the left side, you can see the simple code for drone to move around some markers. So first of all, we import the ROSPY library. We're working in it. After that, we import the telemetry. And you see, starting from the 16th line, you please see the 16th line in Python, we are starting the navigation phase. So first of all, you see the blue word navigate. This is the command for drone to start up engines and to go up. You see that we have put the X, Y, and Z. X is 0, Y is 0, and Z is 1. It means that the drone needs to hang on the marker on the altitude 1 meter. And XY, we write it to move the quadricopter from quadricopter to some distance from the marker. So for example, I need to move to the left side from the marker number 8. Then I will write X is minus 0.5. Minus is to turn left, to go left, and the plus is to go right. The Y, that is the vertical orientation, it is to go forward or backward. If you want to go forward, you have to write plus, and if you want to go backward, you have to write minus. After that, you can see that we have a speed 0.3 per, that is the speed of the drone, and frame ID, that is the mode of flight. And auto arm is true, that is the command for drone to start its engines and to fly above the point. Set effect, that is the light, the luminance of our LED light. We can also program it. We can give some commands to quadricopter to change the light from green to blue, even make some effects. We use it also for initialization for some signals from the drone for some tasks. For example, we had a task to initialize the COVID areas, and when it was a QR code, the drone has to initialize this QR code, and if the information on this QR code was that is an infected area, the drone was illuminating by red light. So that is why we also need to control the LED light. And then you can see that each next line from 20 to 14, that is a simple navigate from one Aruka marker to another. So you see, for example, that then we go to the Aruka marker 104. The XY is again 0 because we don't need to go left to right or back or forward from this point. And the altitude we have 1 and the speed 1.5 per second. The next point, for example, Aruka 88, you see that Z is already 2.2. That means that we are increasing our altitude to 2.2 meters. So this shortly exploration how we got it, how to make the drone to fly. And from the right side, you see the web terminal of our drone. I already told you that we connected by Wi-Fi standard from our devices. We use this IP address, and you can see that we have different options of our drone. View documentation, that is just our documentation, some instructions how to use. View image topics, this is the topics where you can, that is the page where you can see the image from your bottom camera. If you need to prove, to check your camera if it works properly, you go there and see the online translation from your camera. A web terminal, we use it to put inside the drone some programs to code and to make some comments. Once again, when we will fly in our flight zone, we will demonstrate you how to put the code inside, how to write a command to fly. 3D visualization, you can see the visualization of your drone in a 3D space. It is okay for programming to see how it feels in a space. And also 3D visualizations for Marcus map, you just include the Marcus map in your visualization. So that is all about the theory of programming. So I guess you will have some questions now, so I will gladly be able to answer it. So please ask your questions about the autonomous flight, about the coding. If you don't have questions, we are ready to fly, Anton. So if you don't have questions, but if you do, please ask now.
So actually, I would have a question when I'm thinking of this, because we are coming from the business context, and now I'm thinking how to make a business of this autonomous flying drone. So if I want to use your autonomous drones in my parcel delivery company, okay. So how would this autonomous flight need to be coded, need to be coordinated? How would it work? How could you set up something that could work for me to deliver in a, I don't know, range of 5 kilometers? How could I arrange flights with the drones for my small parcels?
So do you have a question about the long range usage of the autonomous flight drone? Yes. Yes, about
how big can I create my area?
So it depends. Oh, sorry, I have interrupted you. Please continue.
No worries. How big can I create the area for the deliveries? How many of the drones would I need? How many can I operate all in parallel? How would it work?
If you do so, I could give you one example about our newest project. We have one project in Hull warehouse inventory using the drones. And for example, I already told you about the Ruka Marcus. So we are now talking about the practice side of this theory usage. So we do have a Ruka Marcus. The biggest advantage of the Ruka Marcus that you can place them not only on the floor. You can place them also on the walls or on the I have forgotten. Somebody help me. Yeah, I know that some Russians are here. Как потолок на английском?
Ceiling.
Thank you very much. Cooperation with Russians. Really nice. So you can place it also above the drone. So imagine we have. Yeah, a little bit late, Anton. Now I'm answering the questions. So. You interrupted me. I have lost my line of mind. Okay, we do have a big warehouse. We put this Marcus above, and we have, for example, 4 drones. We can launch them from one computer, and we connect to this small computer, for example, the AirFit reader. And our drones are starting to get through these shelves, through the shelves of the warehouse, from right to left, and so on. And they are making the inventorization of our warehouse. So they do not interrupt the workers of the warehouse. They do not interrupt the other processes of the warehouse because they are working automatic and they are working on the high altitude. They don't need to go down because RFID technology allows us to initialize some guts, some containers from 1 to 2 meters. So we don't need to go down. And if we are talking about the delivery, of course we can fly by nav, by Sputnik, by navigation, and we just put the route markers to the drone point. We have some models of drone point. If you want, we can also show you them. We put the route markers on this drone point. When a drone comes above this drone point, he sees the route marker. He understands that he needs to land on this drone point. Then he lands and deliver the your goods, your things, everything you put inside the drone. If we are talking about the range, so once again, it depends on the weight of delivery, and it depends on the battery. Once again, with this battery and with not very big some cells, we can deliver it to 6 or 7 kilometers, also automatically. So something like this.
Many thanks, Nikita. This is a great explanation.
Okay.
Thanks.
Okay. I'm really glad. So any questions left, or we are ready to go to our flight control done? Any questions yet?
Maybe a question regarding the indoor positioning. Have you trialed between the Bluetooth beacons versus these QR codes versus RFID? Which one is the best in the warehouse environment, for example?
So now, in this time, we have already completed the inventorization with the QR. So it is really good. It is really easy to make inventorization with the QR codes. We just put this QR to the containers and it works. But if we are talking about the RFID, we haven't done it yet because we are waiting for one part to our Raspberry Pi computer. But if you want to cooperate with us about this project, you can just send me or Nikolai your email address or some other contacts, and we would be really glad to cooperate with you about the RFID. We can also send you our results of this investment.
How about the Bluetooth beacons?
Sorry, Bluetooth?
Yeah, Bluetooth indoor navigation beacons.
No, we are not using the Bluetooth indoor navigation yet. But yeah, it is possible, but we haven't done it yet.
Okay, thanks.
You're welcome. So any other questions?
Yeah, I had one. Do you feel that the biggest challenges or the most important ones with drone development are software-based or hardware-based? So is the biggest problem in the coding or the actual materials or structural?
Really good question. Really good question. The most challenging way is the stable flight of the drone, because of course we are working with the drones that is a really heavy and really hard technical mechanism. And sometimes, of course, it can fall and it can go to the wall, to the window, to the man. And of course, when we are working with such machines, the safety is the most important part for us. We have a lot of issues when you write a good code. When you have done everything okay, the simulation goes well, it compiles, it works. But when you download it to the copter, something goes wrong and this copter just goes down. So the most challenging way is to combine the software and the hardware part, because not every time the hardware of the drone comes very good. And the software can be great, but it will not fly because of some issues in the hardware. So yes, the most challenging part for us is the stable flight of our drones.
Yeah, so just to recap, the biggest benefit would be to find better solutions on the hardware side so you could more safely test out your software now.
Of course, and that is why even when we are flying the autonomous flight, every time we have a special operator who is ready in any second to take the control from automatic to the operator. So he has his remote controller, and in any second he is ready to start controlling the drone, because anytime something can go wrong, and we are of course ready to fix it. So the safety, once again, is really important. And when we have, when not only we, but all our engineers involved will solve this problem, yes, it will be the great benefit. But even then, even now, it is the safety level of this industry is very high because we control every process.
Yeah. So which one is the speciality of your department, would you say? Is it the software or the hardware development?
Now we are working on the software because as I already told you, the hardware part, the technical part, our drones, we constructed together with our great partner Copter Express, Russia. They are situated in Moscow. We are providing the drone construction with them. And in our laboratory, the main part, of course, the software. That is when we are speaking about the drones. But when we are speaking about some other machines, like the planes or something like this, for us, it's better to, first of all, make a hardware. But once again, we are really young laboratory. We are only 1 year old. So first of all is software.
Okay, that's very interesting. Thank you.
Thank you. Yes, Nikolai wants to say something.
And I want to make I want to make some points. Our laboratory is new in our university and allows us to perform full cycle tasks from development and research to practical flights. And we can simulate the real industry tasks and prepare answer for industry. But the special moment about our laboratory is that our flying field is near the laboratory, is the next to the laboratory. So we can make the very short way from idea to practical research. And yes, today we show the software tasks, but our laboratory we can make and hardware tasks too. And it will be the second step in the research and life of our laboratory. Nikita?
Yeah, thank you very much, Nikolai. So, any questions else? So, was it a good answer for you from Nikolai? I guess it was. So, any questions left? Yeah.
Yes, actually, I would have a question in the direction of future development of this project. So, where do you plan to go with your drones? Do you plan to more look into development inside or so indoor flights, automated flights, or would you also look into outside automated flights, or is that too complicated, too complex?
Of course, the great goal is to complicate it, but now we are working in indoor usage of autonomous flight. Yes. But of course, the great goal for us is to make it also outdoor. But once again, we are talking about the inventorization of in-house warehouses. For example, I was working in Lufthansa. I was working in Munich airport. I was working in Lufthansa Technical Logistic company, and there we have a really big warehouse of the plane parts. And there we, for example, for such warehouse, it would be great to use the drones for because there are very lot of shells, very lot of very lot of plane spare parts. And for example, there we can use from 5 to 10 drones for in-house logistics, for in-house inventory. So yes, when we are talking about the in-house usage, we are not talking about a really small space because we are talking about the big space, the big warehouses. There because there we need to use the drones, not in the small one.
Thank you.
So now we are ready for the flying time, and I want to move with you to our flight control zone. There we already getting started. So once again, so we have already sent you the link to our YouTube translation, where you can see the picture from the flight zone. Антон, у тебя с YouTube трансляция идет?
Я сейчас перехвачу тебя пока.
Okay, so I will now give my screen to our flight control zone. So now you see our flight zones. One question: do you see it properly? You see it okay? The big screen, white screen, you see it okay?
Yep.
Yeah. Okay. So you see our rookie markers that I was talking to you about. We have a big field We have a big navigation base, and now we'll start our drone within a second. So we are going to our web terminal. You see all these options I was talking to you. Антон, чуть-чуть помедленнее, если можно, потому что я комментирую также, да? Okay, so first of all, we go to the web terminal. We open the web terminal, and this is it. We have to put the password, our secret password, and then we are ready to start our program. So please, maybe Anton, could you please show us how it looks inside? Could you please see the? Could you please show us the program in the terminal how it looks? So from Nano and so. One moment. One moment. We will now set up our intro. Yeah, that is also the problem about the working with our automatic systems. Sometimes something can go wrong because it's a really hard engineering. Okay, we will now just fix our bottom camera because maybe it was it wasn't a crash, Anton. Это не авария была, мы же его не роняли. So no, it wasn't a crash, but somehow the camera goes out. But within a seconds, we will fix it. So now I want, maybe while we have time, I want to explain something about our airfield. So we have a airfield, the height of this airfield maybe 5 or 4 meters, something like this. It is one of the biggest in-hull airfields for drones in St. Petersburg. Behind our banner, we also have a space. We have a lot of stuff for the drone racing. We are now getting started to produce our course for the drone racing and for the drones championships. And in this hull, we already completed the BRICS Future Skills Challenge, the World Skills Challenges, and so other big championships. So I hope that most of you would be able to visit us not online, offline in real life, and we would be really glad to show you our zone in life. And of course, we will let you to fly in our zone. So now we are perfectly ready. Anton, please wait. I have to explain what we are doing now. So to run the program, you have to write the Python, then you write the name of your program, and then .py. And now you have to push enter. Anton, please. And you see on your screen now that the drone is flying. You see from the debug that it initializes all our rookie markers. It goes from one marker to other marker. You can also see the LED light. It is now red because we have coded to be red, from red to yellow. And I should mention that now the drone is flying by himself. We do not control. Anton, please, Anton, покажи, что ты не управляешь. Yes, Anton is not controlling it. We do not control our drone. It flies fully automatically. And this was also automatically. So that is back to your question about the safety and back to your question about our challenges. Really nice example about the challenge, about the hardware part. Yes, when you have asked me about this is the biggest challenge because the code was right, everything was okay, but sometimes something goes wrong because it is a machine, that is electricity. Sometimes we have some issues, but that is our goal, that is our mission, to find how to use it more efficiently, how to use it more safety. So now we will take it. So maybe some questions, discussions while we are solving this problem. Maybe you want to say something? Yes, of course.
Have you written code so the drone knows how to react to disruptions? So let's say it gets affected by a wind blast and gets off its course. How does it react to that?
If it is affected by wind, it flies in a stabilized mode. It will try to stabilize drone for itself. So when we have a little wind, drone will try to stabilize itself automatically. So it is not a problem. But of course, when we are flying in stormy weather, it is a great challenge for the drone, for every drone, of course. But it has the stabilized mode to solve this problem. Now, why it has crashed now? Sometimes when drone stays on the field connected to the battery for too long, because we was talking with you about some questions about the coding for too long, and all this time the drone was standing on the field. And sometimes it can have some bugs, some problems with its memory, with its brains, while it stands a lot of time not flying. So it was a great example of it. So we will try to. We will not try. We will start it once again. Yes, we hope so.
So, do you somehow get data about what the drone thought it was doing, basically. When something goes wrong, do you have an idea still that okay, the drone thought it did that, but let's say its altitude wasn't calibrated right, or
do you mean log files about the issue?
Yeah. But
yes, of course,
exactly.
if we write it in the code, yes. But now we are flying with our test code, and we do not have some logs in our terminal. But of course, we can do it. When you have some problems in your code, when you have some errors and mistakes in your code, you have some messages about errors in your terminal. So if you have done something wrong, it does not compile, and you push the enter button, drone will not fly, and you will have a message in which line you have error. So
yeah, exactly. But my point was, like you were saying, that even though your code's right, because you can simulate that.
No. If your code is not right, you will get this message that something is wrong.
Yeah, but still, when you move the code from the writing phase, you don't get any errors. But when you try it on the real life, you still might not succeed.
Yeah, it can be so. But to get the log files about the issues what happened during the flight, you have to put this line to the code.
Okay, yeah, naturally.
Thanks. Okay, any questions yet? We now have time to discuss anything about the drones while my colleagues are changing the drone. So also a big benefit of our laboratory, we have a lot of drones, so we can change them like others. So if something goes wrong with one drone, we just change it. So now we have the new drone, which is, I hope, ready to fly. So while we are set up the new drone, any questions left for me?
Yes, then me again. How long did it take you to develop this? How long did it take you to get here? You said you have the laboratory since 1 year. So how long did you start from scratch a year ago, or did you have a head start with the software or drone hardware somewhere?
So I understood you. We have started the work with the software of drones within 2 years. So we are developing the software for the drones for 2 years. But 1 year was only software because there was no laboratory for us. We didn't have the airfield for our test flights. We didn't have the working space for us. One moment, I will answer the question and we will start. Then within a half year, we have constructed our laboratory, and 1 year, for 1 year, this laboratory have been already worked, something like this.
Okay, it's amazing. I think it's a really quick. Very fast.
Yeah, it was a lot of our partners and friends are also telling us that it is a record to do it in such short time. Okay, we are ready for the next flight. Yes, one moment. We will just check the drone in the flight mode, in operating mode. It flies well. It is good. Yep. And now we have launched our program once again. So you see the light is also changing. You see that now it works well. Now it completes all roads. For example, it can be also the warehouse shelves. It can be all other spaces. Sometimes you see that the drone moves not straightly. That is also depends on the hardware on some occasions. Maybe light is not so good for the camera because when we are using the camera for the drone positioning, of course, the important thing is the light. Maybe we have to change some light here. But on the screen, I see that it initializes all markers great. You see that we also have some color markers. We have used it for our last championship. So the drones can even initialize the colors. I already told you that the drones are open source platform, open source technology, and that is why you can write any codes and programs for the drones and use them in all other any occasions. So we have completed our flight. Anton, could you please show us the nano code? So please enter nano and show us the code. Anton, nano, first nano. Now we will show you how the code looks inside the drone. Enter. So this is the similar code I have shown you in a presentation, and that's how this code looks inside the memory of the drone. To get there, you have to write the command nano, and then you go to the code file. So this file is inside the drone memory, not inside our computer. So this is what I wanted to show you. Any questions from you? You have no questions left. You were just shocked by the first launch. Or... So okay, if you have a question.
Yeah, not really a question. I'm just stunned. I think this is fantastic technology, and I think we are moving in an incredible speed in this technology. So I believe that we will quite soon be there also in bigger applications of it. So it's for me it's an amazing project.
Thank you.
Just many thanks.
We are really glad to hear it, and really thank you. So, Nikolai, please. We have a stereo sound. So, any else questions? I guess you have, or no? So, okay, if we do not have any questions left, please, Nikolai, I give a word to you. You are going.
So thank you, Nikita. As you see in real time in YouTube channel 2, the flight zone, our research laboratory, the drone systems. So at this moment, we have some industrial projects, and we are open for the cooperations, and we are open for the making a joint project. You and we can give a joint project in the sphere of drones, named aircraft systems or simulation, the real task. At this moment, this is a very new laboratory in our university, and we have a full equipment from computer, from 3D printers. All technologies is here for the some hardware and software capacities. We can make it all. So, could you give me your opinion, some words about this information about our laboratory and this seminar?
Yeah, from my side, I want to thank you all for participating today with us. I also want to say that for us, that is the first experience in an international seminar. Of course, something could go wrong today, of course, some technical issues or my issues, but for me, it is also a great opportunity to improve my skills, to improve myself in international cooperation with you. And from me, really, thank you for such a great experience. And I and Nikolai, we would be really great to continue work with all of you, and we would be really glad to now hear some words from you, some feedback.
Dear Anya, dear Ivan,
well, I would, Nikolai, I could say,
and we are waiting you in our university. We are waiting your project. You have the contact information about our laboratory, about our science research central, and we're open for the cooperations. And let's together join some research in this field. Next step in this field. We have a very interesting field now, but we cannot show it in this short time. This is a group drone controlling system when we have work or some flight with 6 or 10 drones joined together, and they will make a special flight task. So we can show it on our next seminar. So thank you very much, Ivan, Anya, students.
Thank you. Thank you, Nikolai and Nikita, for running this for us. Thank you, Nikita.
Yes, thank you very much. Thank you very much to all of you. I think it has been very, very inspiring to see all of your achievements there, and I think it was a great opportunity for the students to see what possibilities are there and how we can go on. I personally find it very inspiring also to look into future opportunities, and I'm looking forward to this. Many thanks.
And please, let's turn on the cameras and take a group photo, and we will show the old photos in our group. Ivan, students, thank you very much. Very good. Also smile, it was great. One moment. Thank you very much, and have a nice day, and see you soon together.
Thank you.
Thank you.
Many thanks, all of you.
Thanks.
Bye. Take care. See you soon.
Bye-bye.
Thank you all, and ciao from uns.